Hi everyone, and thank you for joining us today. This is our Masters of Science in Business Analytics Showcase presentation. My name is Avery, and I will be presenting with Benjamin and Enrique. Here's our 6 team members: Darren, Miguel, Brian, Avery, Benjamin, and Enrique. We have been working together for the past year on this GreenTrack project. As you can see, we don't have any titles, and this is strategically done, as over the course of last year, we have filled different roles such as project manager, product developers, business analysts, and more. Quickly, we would like to give some of our partners a quick shout out. Our analytics support team was incredibly helpful in providing guidance on the project, as well as providing operations and technical support. And this project could not have happened without the time commitment from our project sponsors. So thank you all for taking the time and working with us this year. This year can be broken into 4 phases. The initial phase was the project discovery phase. Here we did a market and organization analysis and developed the scope of the project. In phase 2, we began collecting, cleaning, and analyzing data. Next, in phase 3, we began the development of our digital solution and garnered feedback for our solution from the GreenTrack team. And last but not least, in phase 4, we built out and implemented the minimum viable product and began planning for their next steps. In case you aren't familiar, GreenTrack is a Pierce County-based childhood education and advocacy organization focused on supporting the local community. They currently have robust outreach programs, multiple preschool locations, virtual programming, and 2 museums. And they reached out to us this last summer to discuss some of their challenges. Before COVID, child care centers were declining mostly due to prohibitive costs. After the pandemic, these threats and challenges have only gotten greater. And they came to us asking about the potential solutions and how to expand effectively. Although there are many uses for our solution, we identified 3 key use cases: supporting leadership by providing them the data to make effective decisions on expansions and more. For marketing, utilizing the solution to identify unique opportunities and diverse communities such as military and underserved areas. And last but not least, funding. Utilizing the demographic data to showcase need and leveraging these stats in grant proposals and fundraising campaigns. It is critical for GreenTrack to find the properties and areas that they can make the greatest impacts in. In order to do this, we built a machine learning based tool that identifies locations in real time based on GreenTrack's likes and needs. Our solution has 2 unique sides. 1, to help identify available real estate, and 2, to identify the areas within Pierce County that would benefit from a GreenTrack location. Now on to Ben to discuss tech and solutions.
Thank you, Avery. I'm going to start our discussion with a look at the technology architecture that we use to make this turnkey solution possible. Our intention when planning this project was to take advantage of open source and low-cost tools that would be available to our client after we had our handoff. We believe that it is important to build with the end in mind and creating as few friction points for existing users when you present a new tool or new process to them. One tool I would like to point out is Google Suite. Near the end of the project, when we were looking through our options of different software to enable our users to input scores for the model, we leaned on this goal of simplicity to create as seamless of integration as possible. This led us to building an email that would be automatically generated to send specific GreenTrack users in order to solicit their feedback. We know that everyone spends too much time on their inbox every day, so we thought it would be best just to give you another important email. I've talked a little bit about scores in our model, but what data are we scoring and what is the point of these scores? Let's move on to the next slide to learn more. Here's a brief look at the 3 data sources that we use to build out our model. We have leasing and purchasing data from commercial real estate listing sites, data from GreenTrack's customers, and finally, census data from the ACS-5 2018 census. One interesting feature we decided to incorporate was to ensure that our model would provide dynamic recommendations. This meant that we needed to ensure that we were continuing to collect new data as it became available. Our commercial real estate data is updated every day, and we have the ability to update our census information to the ACS 2020 data as it's become available. As this product continues to be developed, we can also create new data pipelines to update our customer information that we are collecting as well. On the next slide, we can see some of the variables that we collected and begin to see how these lead to an AI-driven recommender. Looking at these variables, we can begin to see how the data we collected can be combined to predict new locations that would be the best fit for GreenTrike. These are just a few of the property and census variables that we use. These features are some of what make up the variables that go into the model to predict our score. Now let's look at that score. In order to provide differentiation between locations and properties, we needed to develop a scoring system that would give clarity when we receive scores from users of different properties. These records are scored on a 1 to 5 scale, with the most favorable ones being ranked as a 5. We ranked properties and block groups separately from each other on their own scales. Let's look at see how these scores are provided and how our model uses GreenTrike's feedback to give dynamic, up-to-date predictive power. This is a high-level view of the user feedback loop we developed. Like almost everything at work, it all starts with an email. Enrique will show you a little bit later what this email looks like and the Google Sheet attached to it, but users take the email and that they review properties and demographics for different census block groups within Pierce County. They then score them based on how favorable these locations and properties are. With these scores in our database, we use them to recalculate our predicted scores for the other properties and locations. With this updated model, we then can prepare the next set of properties to be sent to our users, and the loop can start all over again. This loop continues to present new records to users for scoring, and it uses the most up-to-date data to calculate scores in our predictive model. This is a dynamic, self-learning system that will adapt to meet the preferences and needs of its users. Let's take a closer look at how our model accomplishes this. Here is a closer look at the different steps and technologies that we use to make our model work. By following the flow of data, we can see that Python acts as the framework to call all of our other technologies. We are able to use Python to automate all the tasks that would normally be touched by a human. We collect our scores from users, importing them into our database. We can collect commercial real estate records and new records that come with that, and they will be updated to our database as well. With these new records in the database, we'll use Python to call R to run our model with the most up-to-date records. With our predicted values from the model, we can use them to notify GreenTrike of any new insights, properties, or changes that require their further analysis. Finally, a new email is generated, ready to be sent off again to a user. Now let's talk with Enrique, who will show us how these users interact with our turnkey solution.
Thanks, Ben. We wanted to start this demo off with what GreenTrike sees on their end, so that we can then show you the impact GreenTrike has on our feedback loop. As you can see, we have an email here that has been sent to GreenTrike. There is a general purpose description and instructions so that specifically outlines what needs to be done so that any user within GreenTrike can utilize the tool. GreenTrike simply needs to hover over the attachment at the bottom and select Edit in Google Sheets, which pops open a spreadsheet. As mentioned before, we have two main types of data: real estate building data and demographic location data based on blocks of a city. Up above here, you can see we have a select few real estate buildings and their information, as well as links to the real estate listings themselves. Let's take a look at the second real estate location by following the link provided. This takes us to a LoopNet landing page where we can learn more details about what is being leased, as well as information about the property and surrounding areas. So going back to the spreadsheet, now we can give a score from 1 to 5. Below is the associated area by block group with its demographic information, such as population breakdown and income levels. After viewing the data, we can now give this block group a score. This tab is specifically for leasing, and you may have noticed already, but we have another sheet for purchasing, which is the exact same process to provide GreenTrike with more options for expansion. And once the blue bars have been completely filled out, we can then go to File, Email, and reply with this file so that there is no need to download and re-upload to reply. And that completes the process of the feedback loop. By periodically sending this email to continually update our feedback loop, GreenTrike can use this tool dynamically as real estate changes and strategic goals of GreenTrike leadership shift. So let's hop over to Power BI so that we can better visualize the impact of what has just happened here. This is an early iteration of our feedback loop where GreenTrike started to score locations. When we first started getting scores from GreenTrike, we noticed we were getting an uneven distribution of predicted scores of 3s and 4s. The map shows our predicted scores from the scores we received from GreenTrike, and each dot represents a block group which consists of roughly 50 of those block groups of around 600 to 3,000 people on average. On the map, we have high scores in teal resulting from the 3s and 4s, and what this shows us initially is that Pierce County, just seems generally a good place to expand to. We needed to adjust the types of properties that we gave to GreenTrike to give our model a more dynamic range. To the next visualization, we can see that this is a later iteration of our feedback loop where GreenTrike has had the opportunity to score more locations. After GreenTrike was able to provide our model with new scores, we can see the effects GreenTrike has made. This presents a more selective view of what areas match GreenTrike's preferences. You can see that there is still high scores spread out in Puyallup, Frederickson, Grant, and as well as DuPont. In fact, GreenTrike expanded to DuPont prior to this tool, and this helps us to confirm that our feedback loop is predicting according to GreenTrike's interests. Moving on to force multipliers. Here, we can see that our tool has predicted 2,137 areas with only 89 manually reviewed areas, emphasizing that forced multiplier effect. We can now identify certain clusters or locations that GreenTrike can analyze further. If they wanted to expand outside these counties, our product can pull relatively few new block group scores and can quickly perform location analysis for new counties across Washington. For example, GreenTrike in the future can use the built-in census data to grab census demographic information of Spokane and run this exact same model and apply it to this area to generate a preference map like what is shown here to help them identify areas of focus for expansion. And moving on to our last visualization. What we have here is some real estate data and our different scores, GreenTrike reviewed scores and our predicted scores, as well as the difference between the two. Our predictions are from an ensemble model, which are scores from multiple different types of models and their predicted scores combined into one. When the predicted score is green, we have predicted correctly with a margin of error of only 0.5 or half a rank in our scale of 1 to 5. Yellow is when we scored 1 rank difference from what was manually reviewed by GreenTrike. Red is when our predictions were 2 or more difference in rank. So what we see here is an ensemble model that predicts accurately more than half of the time. The number of predicted scores that are accurate to what GreenTrike has reviewed will only get better as users continue to input into our feedback loop, which you have seen at the beginning of this demo with the email response. So now I'm going to pass it over to Avery for our recommendations to close us out. Thank you.
As Ben discussed earlier, the goal for this was a simple, turnkey solution that is easy to begin using for GreenTrike. I foresee you being able to utilize this tool in a wide variety of opportunities. An example of this includes funding, using this as a way to showcase need and validate decisions based off this data. I can see this being very helpful in fundraising, grant writing, and more. As shown in the demo, this is a great way to identify specific communities in Pierce County, and you can use this as a base to facilitate different community pop-ups, events, or running targeted ads. In the same vein, utilizing this data to spur growth and look for potential government support. Also, encouraging entrepreneurs to look into childcare as a service, essentially using this data to prove a need. In general, the project is looking to solve the problem of identifying opportunities and need in the form of community and locations. We encourage GreenTrike to utilize this as a tool that facilitates discussions and allows a quick but deep dive into potential campaigns, events, expansions, and more. If you'd like to learn more about the project, feel free to connect with us over LinkedIn and drop by our Q&A session. We look forward to discussing this further. Thank you.
Hello, everyone. Today, my team is presenting as a part of Livable City Year program, the Parks and Trail Usage Analysis for the City of Linwood. Our client is Parks, Recreation, and Cultural Arts Department, and our client representative is Sarah Olson, the Deputy Director of this department. My name is Monib Sabet. I am the Project Manager for Team A2, and here I would like to introduce my team. Gauri Patil, Kevin McInerney, and Trishali Ranjan. We are all in master's program for business analytics, MSBA, at the University of Washington, Tacoma. Today in this presentation, I will start with a project overview. Then my team will continue with data overview, a Power BI demo, and our project's conclusion. Some background information here. City of Linwood is located in Snohomish County in the state of Washington, 16 miles north of Seattle, and with a population of about 39,000. Currently, the City of Linwood Park System includes 3 trails and 18 parks. With a forward-looking perspective and considering rising value of lands and increase in cost of development, the Parks Department is seeking to adopt a new level of service, which is focused on equity and improved access to parks and trails for all residents of City of Linwood. And to that end, the City of Linwood is working with 2 teams, one from University of Washington Evans School for developing the policy, this new level of service, and the other team is from University of Washington Tacoma MSBA program team, which is our team, and where we are focused on using fact-based and data-driven insights and analysis to support developing that new level of service. We started with a request from the client, and we started this project with a request from the client, and we narrowed down and defined our scope to use location-based park usage data to identify use patterns. And then as a next step, we defined phases and focus areas where we analyzed the parks and trail users, explored seasonal trends, demographic analysis, and the impact of key amenities on the park usage. Our team started on this project in the autumn quarter of 2020, where we started business understanding, data understanding, and data cleaning once we had access to the data. And then in the winter quarter, we started developing visualizations in Power BI and Tableau, and we identified seasonality in patterns in the data, and we also developed a data model prototype and presented it to Linwood Park Board. At the same time, in the same time frame, the client was able to utilize our visualizations and the analysis that we had provided as supporting document in grant application. In spring quarter, we focused on demographic and amenities analysis, which has been of great interest to the City of Linwood Parks Department. And in the next slides, Gary will go over the project data overview. Gary.
Thank you, Moni. I'm Gauri Patel, and I'll be walking us through data overview. So after exploring different data options, our client provided us with most suitable data for this kind of analysis, which is from a third-party data provider company named as Streetlight. Now, Streetlight processes smartphones and sensors to measure vehicles, bicycles, and pedestrians across North America. It processes around 40 billion pings per month and collects data on almost every road, trail, and park in US and Canada. To extract data in Streetlight, we performed analysis by marking geozones on the map. The picture on this slide is actually a screenshot of zones marked for all parks in Linwood City. The key metric in which data is made available is average daily traffic, which is counted in unit trips. Now, the trip is counted when one person using GPS services travels from one point to another without stopping for more than 5 minutes. This is different from a park user in a way that one user can have one or more trips. Now, each trip has a mode, pedestrian or bicycle in our case, considering various factors such as speed, duration, and length. The mode is a medium of travel inside the park or on the trail, which can be different than the medium of transport used to reach there. And this average daily traffic metric is available to us for each month, weekday or weekend, and different time of the day. Now, the total duration for which this data is available is 3 years. The Streetlight also provides us with demographic breakdown using the census data along with their mobility data. And the demographic data categories are income, education, kids in the household, and race or ethnicity. Now, there are few limitations to this data. Data duration is 3 years, one of which is 2020, an exception due to pandemic, which makes it difficult to draw significant patterns. As our data is based on mobile pings from navigation system, we are also losing on a group of park users like kids, pets, people without mobile phones or location services. As none of the parks have counters or historic data for reference, accuracy of our data is also a concern. However, to validate this data, our client has helped us by installing a counter on one of the trail locations. After comparing the counter data with streetlight data, we feel confident about our analysis as the numbers are pretty close. Finally, using this average daily traffic, we calculated total trips per month and then summed them up to get the annual usage for each year. Next, let's take a look at this annual usage and some of the other interesting analysis in Power BI. Now, this big number over here, 5.5 million, is the total number of usage for all parks and trails for both pedestrian and bicycle users for all 3 years. These icons over here signify parks, trail, pedestrian, and bicycle. This first chart over here tells us that the usage in 2018 is 1.5 million, then it rose to 1.6 million in 2019, and finally in 2020 it was 2.45 million, which is a good year-over-year rise considering the growth in population in the Linwood city. The table chart here is in descending order of usage of the parks and trails. So the highest use is Interurban Trail, followed by Golf Course Trail, Meadowdale Playfields, and so on. The pie charts on the bottom show the proportion of parks versus trail uses. We can see that most trips are trail trips. And then this proportion shows pedestrian versus bicycle users. We can see that almost 93% of users are pedestrian users. For the remaining analysis, I would like to pass on to Trishali. Thank you.
Thank you, Gauri. We are now taking step in diagnostic analytics to see the larger picture of the size of our data, to see what causes or possible causes the fluctuation in our data over 3 years, 2018, 2019, 2020. So one way that we have started doing this is to analyze the broken data according to parks and trails, according to the mode of transport and season. This sheet shows 2018 data in green, 2019 in blue, 2020 in yellow. The top visualization shows the park's average daily traffic for pedestrian, while the second visualization shows trails for bikes. In both the visualization, 2020 data shows much higher daily average traffic. This clearly demonstrates usage during the pandemic. Both two visualization in the bottom shows the parks and trail for pedestrian and bicycle by season. There is no uniform pattern you can see for all the 3 years. Next, we will go into the analysis of income groups. So the pie chart here gives us a bigger picture of what percentage of our income group are divided into entire population. Here we can see that the more than 50% of the population is low income group from 0 to 75K, and the bar chart on the right hand side represent the total numbers, that is the actual number of users. So you can see the highest bar here is 50 to 75K, major part of the population. In the visualization below, we try to look at the parks that have a total average income of 75K. We found the highest ratio in Gold Park, Mini Park at Sprague's, then South Linwood Park, and these neighborhood incomes coincide with the average income structure, interestingly. Maple Mini Park is the highest proportion of high income group that exceed 20K, followed by the Meadowdale Playfield. One thing to note here is the Maple Mini Park is a smaller park, and this actual number it will be less than Meadowdale Playfield. So the Meadowdale Playfield is actually a park in one of the high income neighborhood by location. Next. This visualization is looking at the race and ethnicity group for the year 2020 and include both parks and trails as well as pedestrian and bicycle users. So the pie chart on the top left is looking at the total number of users in all the parks and trails of the race system. We excluded Hispanic data because we separated them, which is how census data collect this type of information. In the below, we divided race and ethnicity into park and trails. As you can see, the city of Linwood is dominated by whites. The city of Linwood is encouraging people of other races other than white to use parks and trail system. Below are few parks such as Spruce Park, Veteran Park, and Stadler Ridge Park, which is an area with a greater Asian population. While Veteran Park, the Black population of 9.4% has one of the highest percent of the Black population. So these are the things that see a city of Linwood falling. They have a program called Diversity and Equality. So this is one thing they are following very closely. Next, Kevin will explain our project outcomes and recommendation. Thank you, everyone.
Thank you, Trishali. Hi, everyone. My name is Kevin McNerney, and I'm going to be discussing our project outcome. So the overall goal of this project was to recommend a new level of service to Linwood Parks Department. And the work that our team has done was able to help the Evans School of Public Policy do just that. What's being recommended going forward as a level of service are the metrics like the percentage of residents that live within a half-mile or 10-minute walk to a Linwood park or trail. And the long-term level of service approach that's being recommended is the capital value per person. And what this metric is the total value of the Parks and Recreation inventory divided by the total population. So that's the overall goal of the project. But there were some additional benefits that came about as a result of our data analysis. So the Linwood Parks Department was actually able to use our analysis when applying for grant funding to improve their parks and trail system. Two specific applications where our analysis was used was the Scriber Creek Trail Renovation Project, as well as the Resilient Parks Access Grant. That's an initiative to help make Linwood Parks more equitable, inclusive, and welcoming for the entire community. So moving forward, there are still some opportunities for some interesting analysis for Linwood in this project, like additional data analysis and calibration. As you saw, we were working with 3 years of data, but as more data becomes available, there's more to analyze, and Linwood can get a better understanding of these usage patterns. Origin and destination analysis could be key, especially when talking about a level of service of a 10-minute walk to a park or trail for Linwood residents. And then a deeper analysis of the demographic data. You saw how the percentages of income, race, and ethnicity made up the different parks and trails in the Linwood system, and moving beyond the descriptive analytics to the diagnostic analytics and seeing why these percentages look the way that they do. And then setting up additional geozones in streetlight for amenity analysis and seeing how things like dog parks and playgrounds drive park usage. So going beyond just Linwood and this project in particular, this data analysis can be really useful to any municipality across the country. And they can do really interesting things like help a municipality use their resources more efficiently, identifying which trails need to be renovated or which park could use a playground to increase usage. It could be used to automate maintenance and safety inspection schedules across an entire parks system. It could also be used by a park municipality to become more competitive for grant funding. And then ultimately, analysis like this could be used to help a park municipality improve the relationship with the community that it's serving. So thank you so much. This concludes our presentation. On behalf of our team, I would like to give a big thank you to our client representative, Sarah Olson, who has been fantastic to work with for this past year. And then also a special thank you to Dr. Luke Demirkan, Dr. Michael Halser, and the entire CBA staff for their support and encouragement throughout this process.
Hello, and here with us Team A3. We've been working with the City of Tacoma on their HR data and analytics project. This is our team, myself, Jamila Shokanova. I've been a data analyst on this team.
And I'm Sean Connolly. I've been a data analyst on the team as well as project manager for a couple of quarters.
My name is Katie Johnson, and I've been the assistant project manager.
My name is Jacob Jurecki, and I've been a data analyst on the team.
My name is Mrudula. I have been a data analyst for this team. I'm Pansy. I'm a data analyst of this team.
We partner with the Matt Johnson and Cheryl Bildelman from the city of Tacoma. So this project, mainly the HR department is looking to partner with us, consultants, to help them better understand their large unstructured data, to provide insights about recruitment and hiring, equity and diversity, and workforce planning.
For that, first we would like to brief you about the scope of the project. In the scope, we mainly focused on preliminary steps like gathering the data, modeling the data, data storage, data architecture management, and we designed a roadmap how we are going to organize and analyze the data, which helps us to achieve the main ideas that relate to the goal we set formally to proceed further. And this project will provide the department's ongoing efforts to fulfill strategic plan objectives and support the city's equity and empowerment framework. And this project will play a key role in ensuring that the executive leadership is adequately informed as they make service and program decisions. In addition, this project will help the city to better understand and adapt its hiring and employment practices and help them to ensure that the process are efficient throughout the organization. And the main goal of this project was to create a usable, well-structured, and predictable visualization tool for the city of Tacoma HR department, which will allow them to automate reporting and enhance workforce management. And this solution will incorporate Tableau as the visualization tool. We incorporated additional value-added proof of concept analytic solutions to present the city of Tacoma with future opportunities. In order to achieve the project goal, we offered a 4-step process as initial objectives. First, we determined what unstructured data exists in the city servers that we able to use to satisfy current manual reporting requirements, and then plan to display in dashboard metrics that correspond to key performance indicators determined by the city of Tacoma HR employees. For that, we mainly focused on the transform and load part of ETL, that is pulling the data from SAP and integrated the same into Tableau. After that, we planned implement a procedure to ingest NIGO data obtained during the solicitation phase of recruitment to better inform hiring actions. And then we plan to create a predictive model using available data to help inform attrition or failed recruitment such rates. Now I hand over this presentation to Pansy to explain us about the high-level architecture.
So City of Tacoma employee extracted the original data from city database servers, and then we download it and move to University of Washington Tacoma SQL server. We ingest data to R for analysis and ingest into Azure for projection. Besides, we load data to Tableau to meet City of Tacoma's requirements, and we also have Azure Output Excel file that it then can integrate into Tableau dashboard. Next, please.
For the descriptive analytics portion of this project that we did early on in the project, we wanted to create some visualizations for the city of Tacoma to look at their EEO data that they had. A couple of different visualizations that we came up with, as you can see here, are being able to look over time of how diversity has changed within their organization, to be able to, for them to measure whether or not they are reaching their diversity goals. And then also being able to look at different KPIs across gender, for example, as you can see in the bottom left-hand corner. And then also creating some heat map style visualizations so that they can look at a lot of KPIs at once by department. Next slide, please. So a lot of the questions around diversity, we wanted the city of Tacoma to be able to self-serve by looking at our dashboards to see whether or not they were reaching their goals given the data that they had. One such question, for example, is whether or not the diversity that they have within their organization matches the diversity within the workforce of Tacoma. So we created the visualization here on the right to be able to look at how that diversity compares. Dashboards like this will help the city of Tacoma, even after this group A3 is done, because they will be able to upload new data into this dashboard pretty easily. And it's also using the tool Tableau that they already have some expertise with. Next, Jacob is going to be showing us the predictive analysis.
Thanks, Sean. So for our predictive analytics, what the city wanted us to look at was whether or not we could predict if an employee would be leaving. We were initially given some demographic data for city employees, as well as a couple other data sources that the city believed could be a factor in those employees leaving. What we had to do was first combine the data, and we did this both in Excel and we did this in SQL Server. We did this in Excel so that we would have a model for the city to be able to use when we gave this back to them as a product. The first thing we did is we modeled this data in R to see whether or not it was even viable to go forward with a predictive model. Once we were able to determine we had a predictive model that could be used, we took that model and we moved it into Azure Machine Learning Studio, because Machine Learning Studio is a little easier for a first-time person to use. And we knew that if we were going to turn this over to the city of Tacoma, it would be nice for them to be able to use this model in real time. Once we had that model created in Azure, we tweaked the model and we did factor importance, looking at what would be the most important things that we could look at for attrition. And then we did enrich that data throughout the year. City employees came back to us and said they had additional data that they had received that may make it better, may make our model better. So we went back in to Azure and used that new additional data to see whether or not it helped with our prediction. We kept a small holdout set that we tested our model against. We wanted to make sure that our model didn't just learn the training data, but that it actually did prediction. One of the other things we wanted to do was create both inputs and outputs for the city so that this wasn't just a snapshot in time for them. So we created a web service input that would allow them to incorporate any new data that they received. So if any new employee was hired, they'd be able to easily input this information. The other thing we created for them was a web service output. So after they loaded in an Excel document with their new data, it would also output for them a scorecard for each record. And this scorecard would be a prediction as to whether or not that individual would leave after a certain period of time. This was our first value-added analytics. Our second value-added analytics was done and will be presented by Katie Johnson.
For the final quarter of our program, we're working on cognitive analytics, and the tools that we're utilizing in our analysis include Microsoft Azure, Power BI, and Python and Google Collaboratory. The data set that we're working with are the results from the city's employee engagement survey. The main focus of this part of our project is to use key phrase analysis to identify themes within the survey comments across different departments. Based on these key phrases, we are categorizing the comments into different buckets and to summarize and understand the data a little easier. In addition to this, we're also using sentiment analysis. In the following slides, we'll explain each type of analysis in a little more detail. So first, we have sentiment analysis. Since the data we are using is confidential, the example output I have on the screen was taken from a Kaggle data set on Glassdoor reviews. So how it works is a sentiment label is applied to the document level, which in this case is a survey comment, and at the sentence level. Each are given a confidence score between 0 and 1. The closer to 1 means that the model has a higher confidence that the label applied is accurate. The closer to 0 means the model is less confident. Here, the overall sentiment was mixed, which means it was made up of both positive and negative sentences. For our data, we'll be taking all the survey comments, running it through a sentiment analysis, and using the overall document sentiment score. Things that can impact your score would be the quality of your data, whether or not proper punctuation was used, or if the data included mixed languages, because the model can only recognize one language at a time. On the next slide, we have key phrase extraction. The example below is from our survey data set. And so key phrase extraction outputs are mainly made up of nouns and objects and are listed in order of importance. So for instance, how many times the word was used. And we also removed any non-essential words such as a, the, into, because they don't add a lot of value. In this example, we paired the key phrase extraction with sentiment analysis, and this is important because certain words and key phrases can hold different meanings depending on how it was being used in a sentence. So without the sentiment, your results could potentially be misleading. In this example, we have the different types of sentiment labels on the left with their corresponding key phrases on the right. And so this example was positive, mainly talking about benefits in the department. And our last example is text categorization. And so we also paired this with sentiment analysis. And the way that this works is that you have to start with a training set of documents that have the labels that you want already applied. So in our case, we're going through all of our documents and applying the labels and creating our training data set. Once we have that, we can run it through the machine learning algorithm, do some tweaking, and once we're satisfied with the performance, and in this case, it would be accuracy, we end up with our trained model. From there, you can run any new documents that you have through the model, and the model will apply the categories for you. An example of how you can visualize this is on the screen, where we have the categories with the counts of comments in each category with their respective sentiment breakdown. This will help the city understand not only what their employees are talking about, but how they actually feel. And so everything that we've done this quarter is taking the raw text data, visualizing it, and turning it into actionable insights that the department can use towards achieving their goals of attracting, developing, and retaining a talented workforce. On the next slide, we have our final recommendations. And so our main recommendation would be to make data integrity a priority, standardizing the data types and formats to make joining data sets easier, updating their data on a regular cadence, make the transition to SQL Server instead of data entry into Excel, and making sure that they're saving any data onto the company server instead of on personal computers. We also recommend that they start tracking additional metrics that could be used in a predictive model, such as work center data, any office locations of each employee, and the distance traveled to work.
And finally, we would just like to thank the City of Tacoma and the University of Washington Tacoma for the opportunity to work on this project. Thank you so much.